All right, champs, today we're going to be talking about arc length and sector area. So if you didn't print these off and if you're taking notes by hand, make sure you're labeling them with arc length and sector area notes. At the top there, I have put some warm-up problems that I want you to try. So go ahead and pause the screen for a second, and I want you to try the problems that are in this top box here. Sketching an angle of negative 315 degrees and sketching an angle of 19 pi over 4, and then finding the positive and negative coterminal angles. Pause there, we'll go over it in a minute. If you tried out the first set of problems and sketched negative 315 degrees, you'll notice that it's negative, so you should have gone backwards from that positive x-axis and landed in the first quadrant. It does not make it around a full rotation. That would be negative 360. So make sure your angle lands in the first quadrant. To find two positive coterminal angles, take your angle, add 360, add a full rotation. You should have gotten 45 degrees. Take that same 45, add another 360 to find another coterminal angle. So you get 45 degrees and 405. If you keep adding 360, you'll find unlimited coterminal angles. Same with negative coterminal angles. You just subtract full rotations. Remember, all a coterminal angle is an angle that has the same beginning and to end point. When you look at the problem on the right, 19 pi over 4 is bigger than 2 pi, so it's bigger than two full rotations around the circle. So I subtracted 2 pi right here. Subtracting 2 pi is the same thing as subtracting 8 pi over 4. So then you get to 11 pi over 4. 11 pi over 4 is still bigger than 2. 11/4 is bigger than 2. So we took that again and subtracted 2 pi again to get 3 pi over 4. 3 pi over 4 is like 3/4 pi. So we went around once, that was the first 2 pi, twice, that's the second 2 pi, and then 3/4 pi, or 3 pi over 4, should land in the second quadrant. If you don't like that radian stuff, you can always change to degrees, and that is what I did up here in the top right. Took 19 pi over 4, multiplied by 180 over pi, you get 855 degrees. Then you can keep subtracting 360 until you get an angle that is within your regular 360 degrees, and you'll find that it's, I think, 135. It also lands in the second quadrant. If we wanted to find two positive coterminal angles, we can take 19 pi over 4 and add 2 pi, which is the same as taking 19 pi over 4 and adding 8 pi over 4. Add straight across, and we get 27 pi over 4. You could keep adding 8 pi over 4, so take 27, add 8, get 35 pi over 4. Those are just two options. If you got different ones, it doesn't mean you're wrong. To find two negative coterminal angles, take 19 pi over 4, subtract 2 pi. Now you'll notice that we don't get a negative angle right away. If you take 19, subtract 8, you get 11 pi over 4, another positive coterminal angle. So subtract 8 pi over 4 again. You get 3 pi over 4. Still not negative, so keep subtracting. 3 pi over 4 minus 8 pi over 4. Get negative 5 pi over 4 is a negative coterminal angle. Subtract 8 again, and you get negative 13 pi over 4. So that's it for review. Today we're going to be talking new stuff about arc length and sector area. So we're going to start here with arc length. I first want to give you a visual of what that actually is. If you have a circle, when you find arc length, you're going to be given a piece of that circle that's going to be determined by an angle, theta. Arc length is finding the length of that pizza crust that the arc cuts. So some key variables here that you're going to be dealing with. Theta, you're going to need to know your radius, and the variable for arc length is s. Now don't ask me why arc length, which has 0 s's, is labeled s. It just is. The formula for arc length, the arc length is equal to the radius times theta. You might want to put a big happy cloud around that. And then I want you to add this happy tidbit of knowledge that is a must know. That theta that is in there must be in radians. Do not plug in degrees to that formula. So let's try a real basic one down beneath here. We want to find the length of the arc cut by a 120-degree angle on a circle with a radius of 2 inches. So we've got a circle here. We have a 120-degree angle. Now, just like I said before, that 120 degrees needs to be in radians. So we're first going to take theta, that angle, and turn it into radians by multiplying by pi over 180. Simplify 120 over 180, and you get 2 pi over 3. So we know our angle in here is 2 pi over 3. We know our radius is 2. And now we're trying to find the length of this arc right here. All you're going to do is use that formula that you see above and plug in. So S is equal to R times theta. We know the radius is 2. We know theta is 2 pi over 3. You can stick that 2 over 1 and multiply straight across to get 4 pi over 3 inches. Or you can write it as a decimal by putting 4 pi divided by 3 in your calculator, and you get 4.2 inches. So this is correct, and this is correct. So key thing, you're just multiplying the radius with the angle as long as the angle is in radians. Let's try out the one right beneath there. We want to find the length of an arc given that the radius is 5 meters and theta is 2. Now, you might be thinking, that's a weird theta, 2? If it doesn't have degrees, then we can assume that it is in radians. So this is already in radians. We don't have to do any changing. So if there's no degree, it is already in radian form. So we know S is equal to R times theta. The arc length is equal to the radius times theta. The radius is 5. Theta is 2. So we get 10, and it's an actual length, so make sure you're putting your label on there. 10 meters. And our next one, we want to find the measure of an angle in degrees and radians that cuts an arc that is 8 feet long in a circle with a radius of 14 feet. So let's think about what we know. In this problem, do we know the arc length? Well, it says it cuts an arc that is 8 feet long. So in this case, we know that the arc length is 8. The radius, they tell us, is 14. We do not know what theta is. We'll isolate theta by dividing by 14. We get theta is 8 over 14. If you reduce that, you get 4 over 7. Now, is that degrees or radians right there? Well, the theta that comes out of the problem is in radians. So if you need to make a little note, we have found the radian measurement. The problem also asks us to find it in degrees. So we have to take that 4 over 7, and to change it into degrees, we're going to multiply by 180 over pi. If you multiply straight across, you'll get 720 over 7 pi. A couple ways you could do this. If you're multiplying in your calculator, you can put these two fractions both in parentheses when you multiply in your calculator. Or if you're going to get it to this step, make sure that 7 and pi go in parentheses. Otherwise, your calculator will just do 720 divided by 7 and then multiply by pi. So if there are multiple numbers in the denominator, you need to make sure you wrap them in parentheses. You know you've done it correctly if you get 32.7 degrees. For the sake of time on these notes, we're going to skip these remaining problems. Let's go to the next page. On the back here, we're going to be talking about sector area. So just so you can get a visual of what you're actually finding compared to what you were finding on the first page, you're still going to be dealing with a circle. You're still going to have a sector of that circle cut out based upon an angle theta. You're still going to be given information about a radius to determine the size of the circle. When you're finding sector area, though, we're finding the area of that pizza. So if arc length is like the length of the pizza crust, sector area is how much area that pizza slice takes up. The formula looks like this. Area, sector area, is equal to 1/2 theta times your radius squared. Or another way to think about it, the area is equal to theta times the radius squared divided by 2. So you might want to whoop, 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 happy cloud that guy. You'll be using that formula all on the back. And hopefully you're questioning in your head, well, this theta, is it the same as the theta on the other page? Yes, theta must be in radians. Let's give this a shot. In our first problem here, we are asked to find the area of a sector given that the radius is 10 feet and theta is 1/2. Remember, if that theta does not have a degree, it is already in radians. You love it when it's like that because it saves you some time. So we plug into our formula. The area is equal to 1/2 times theta, so 1/2 again, times your radius squared, so 10 squared. You can plug that all in the calculator, or you can probably do it in your head. 1/2 times 1/2 is 1/4. 10 squared is 100. What's 1/4 of 100? 25. Now when we label this, we're going to want to make sure that we label it with the appropriate unit. So since we're talking about area, it's not just feet, it would be feet squared. Taking it to a more, taking it to a word problem, if we look down here, all you golfers, maybe you watched the PGA tournament last weekend. You can think of that as we do this problem. A sprinkler on a golf course fairway sprays water over a distance of 70 feet. It rotates through an angle of 120 degrees. Find the area of the fairway watered by the sprinkler. It might help you to draw a visual here so you can actually see what's happening. We've got a sprinkler. It's spraying a distance of 70 feet. 70 feet. And it's spraying over an angle of 120 degrees. So we are now trying to find how much grass, how many square feet of grass is being sprayed by that sprinkler. First things first, what do we have to take care of? This degrees. You cannot plug degrees into the equation. So we're first going to take 120 degrees, multiply it by pi over 180 to change it into radians, and we get 2 pi over 3. Then, once we have it in radians, to find the area, you can plug it right into the formula that you have up above. 1/2 times theta times your radius squared. Since it's a word problem, you can plug, I would take each of these pieces, put them in parentheses, and plug them in the calculator when you multiply them. So take 0.5 times parentheses 2 pi divided by 3 times parentheses 70 squared. You should get 5,131.3 feet squared if you've done it correctly in your calculator. If you have specific calculator questions, I would log back into the question and answer portion so I can show you buttons on the calculator. If you need help with that, please ask. Okay, similar problem down below there. I want you to pause the screen and try it on your own. All right, I drew a little picture to help us out here. So we got this radar beam being sent from the airplane. It goes 60 miles away at an angle range of 150 degrees. Hopefully you're thinking, oh, the first thing I need to do is change that 150 into radians by multiplying by pi over 180. If you simplify 150 over 180, you get 5 pi over 6. Then you'll take that and plug it in for theta into your equation. 1/2 times theta times your radius squared. I would wrap each of these in parentheses when you're multiplying in the calculator. If you've got yourselves 4,712.4 square miles, you got yourselves the right answer. Your homework will cover that sector area and arc length. Log back in to question and answer time if you have questions on any of these problems, and I'd love to help you. Have a good one.